So if I gave you this figure and I told you this arc measure was given by the letter M, what would be the measure of this central angle? I'll call A. Central angle relates to an intercepted arc by what? John? Yeah, they're equal. So A is going to equal M in this case. And so that's for central angles. Okay, what if I gave you the following? What if I gave you an angle whose vertex lies on the circle itself? And so if I call this angle B, how does B relate to that intercepted arc of M? Yep, M. So B is going to be 1/2 M. So this is an example of an inscribed angle. An inscribed angle has a vertex on the circle, and it's equal to 1/2 the intercepted arc. Okay, what if I take the following? Okay, so I think this is all that we reviewed, or all that we covered. And there's two other instances or potential ways that arcs and angles can relate in a circle. And the first is if the arc, or if the angle's vertex is in the interior of your circle. So if I look at this set where I have this intercepted arc of M, but I also have another intercepted arc. So again, here's one intercepted arc, but I also have this second one. If this is the case, and let's say I call this N, and let's say I call this angle on the inside here C. Okay, so this angle C has a vertex right here that's located in the interior of our circle. And the relationship that exists when an angle has a vertex inside the circle or in the interior of a circle is it's going to be 1/2 the average, or 1/2 the sum of the two intercepted arcs. Okay, so basically this angle C has a vertical angle pair here, right, which are identical, so it's also a value C. And that measure is going to be the average of the two intercepted arcs. And the average is the sum of them divided by 2. Okay, so this is true when the vertex is in the circle's interior. Okay, so anytime the vertex is in the circle's interior, you're dealing with 1/2 the sum of the intercepted arcs. Okay, the last case scenario looks like this. And that last case is, what if our angle, we'll call this one D, what if the angle has a vertex in the exterior, or on the outside of the circle? And we're still intercepting these same two arcs, M and N here. Again, an intercepted arc is an arc that falls in an angle's interior. And so as far as the terminology goes, intercepted arc is the portion of an arc that is in the interior of an angle. So here M and N are the two intercepted arcs of angle D as well. And the relationship between these is when the vertex is outside of a circle, the angle measure is 1/2 the difference of those intercepted arcs. Okay, so this is when the vertex is in the exterior of a circle. Okay, so those are the 4 different relationships you can possibly have. Okay, now if you interpret a central angle as being this category, because that is true, right? In a central angle, the vertex is in the interior. Well, I mean, like the same thing is going to hold true. If this is, let's say, 80 degrees, and the vertical angle, if you were to draw it, is 80 degrees, then what would you anticipate each of these arc measures to be? 80. And would it be true that this angle in the interior of a circle is equal to the average of the two intercepted arcs? And it still fits this pattern. It's just simpler to say it's equal to the central angle. Play by hand. So let's go ahead and we can start talking through them a little bit. So angle B is this case right here. Angle B has a vertex in the exterior. So the measure of angle B is going to be 1/2 the difference of the arcs that are intercepted. So we take the furthest one, the bigger one, 64 minus 20. So what is 64 minus 20? 44 divided in half is 22. So we get angle B to be 22. AEF, that's an inscribed angle. The vertex lies on the circle. So it's going to be half the intercepted arc. So the intercepted arc itself is 64, so half of 64 is 32. Okay. Angle CDE. Measure of angle CDE has a vertex in the interior of a circle. So it's going to be 1/2 the sum of the intercepted arcs. So the arcs are 20 and 64. So if you add those together, you get 84. Half of 84 is 42. So that would be the measure of angle CDE. And then finally, angle AGF is a central angle, so that's going to have a measure that is identical. It's equal to the intercepted arc, so 64.